Let's talk about the exterior angles of triangles. An angle formed by extending one side of a triangle beyond a vertex is called an exterior angle. Okay, so we have a picture here of a regular type triangle. This side right here appears to be extending past that vertex. And when it does that, we create an angle on the outside, which we call an exterior angle. It's on the outside, hence the name exterior. With respect to that angle being named the exterior angle, the three angles that we have on the inside can also be given names. This will be called the adjacent interior angle, adjacent because it means next to. Okay, so it's interior because it's inside, adjacent because it will be next to the exterior angle. The other two are going to be called the remote interior angles. Remote means away from. Okay, if this is adjacent and next to it, these two are away from the exterior angle, which means that they are remote. They're also interior because they're inside of the triangle. The exterior angles of a triangle theorem states the measure of an exterior angle to a triangle is equal to the sum of the remote interior angles. All right, so how could that be true? How could the angle that's out here be the same size as the two angles that we've got there added together? Well, it comes down to two things. First, the adjacent interior angle, that one right here is making a linear pair with the exterior angle, right? We extend out that line and we get a linear pair. So that means that this angle right here would be the supplement to the exterior angle. Second, the three angles that are inside, all of the interior angles, those are going to add up to 180. So let's kind of think about this here. These two with the adjacent interior angle are going to add up to 180. The exterior angle with the adjacent interior angle adds up to 180. Okay, so we got two things that add up to 180. Both of those use the adjacent interior angle. So if we take that out, we come to the conclusion that the exterior angle would have to be the same thing as those two added together. In example 1, we're being asked to find the measure of angle JKM. JKM is located here, which means that it's our exterior angle. Okay, and we're going to figure out what the measure of that would be. Our theorem tells us that the exterior angle is going to be the same size as the sum of the remote interior angles. This right here would be the adjacent interior angle. Okay, so these will be our remote interior angles. All right, that means that 2x minus 5 is going to be equal to x plus 70. We can go ahead and subtract an x from both sides. X minus 5 is going to be equal to 70. We can then add the 5 to the 70. That gives us x is equal to 75. All right, so if x is equal to 75, we can take that and plug it into the expression. 2 times 75 is going to give us 150. 150 minus 5 gives us 145 degrees. That should be our answer. Now, just for the sake of checking some things here, we could go ahead and take the 75, plug it into this spot. We get 75 plus 70, which of course is also 145. So that checks out. You can even figure out that the adjacent interior angle would be the supplement to 145, which of course would add up to 180 here. That angle, just for the sake of writing it down, would be 35 degrees.
Wait, what?